Alright, so we're back just to go over our Space Invaders thing. I know I said at the last video this was the end of this video about this, but we're going to stick with it. So there's just a few things. So the last time we did this, there were quite a few bugs, so it didn't quite finish the way it was supposed to finish. But we'll see if we can go through it. All of those bugs have been fixed, and now this is being released. So I think the first version that was released will actually work. But there are a few quirks, and I'm about to release the second build, and this is basically also me just double checking everything works. So we start off, it all works, so we have our game, but there are a few little quirks. I don't know if it's going too fast now, but the main problem is it doesn't actually, well, that was a bit weird, it doesn't actually speed up the more sprites you have. Now the problem that you're going to have, first off, we are going to, hold on, I made some exporters. So we've got an HTML exporter and a Scratch exporter, and we're going to run the exporters, and everything is fine. So everything was fine, and this has produced this pile of code here. So we have our Scratch 2 file. So I wanted to actually talk about, so the last time I did this video, there were some interesting little quirks, and then it wouldn't actually load properly into Scratch 3. So I'm just going to start up Chromium, because I don't use Chromium, and this way everything is fine. So hold on a second. Probably should have got it going before I started the video. There is a quirk that is going to come up, and we have to come up with a slightly different way of coding things, and while we're doing that, we will make it so that it speeds up as there are less and less So here's Chromium, and we're going to shrink it down a bit, and we're going to get back a Space Invaders game. So we can test it by just dragging this onto our web browser, and so here you can see is the game, and this all runs. So we can go flag. Now I don't know if it's obvious, but this is actually faster than the original version. So we'll see if we can get them going at the same time, and then you'll be able to see what I'm talking about. We'll start the game. You should be able to see that those are actually, or maybe they're running kind of at the same speed. It's a bit hard. There's also the problem, of course, is that these things can get to the bottom and not kill the player. Have I actually been hit by anything? Well, I can die, so all of that's working. The sound effects do work. You can't hear them, but they're there. Alright, so we've got a few problems. Now, I'm pretty sure that it's actually running at a different speed, but that could just be me. Yeah, I think that's going slightly faster. So, but if we, just for a second, I'm just going to go to Scratch. So I have a bit of a cough, like I did in another video recently, in the actions and scenes video. So I may cough in this video, hopefully slightly less. So we've got this. That's our thing. So the export is correct. As you can see, the HTML export doesn't let you do anything. You can go full screen though, which sort of works. It used to work better than that, but hey. What is it? Why does it have that on the side? It never used to have that on the side. Well, it does now. So flag. Why does it not actually work? Flag, full screen. Maybe it just doesn't like Chromium. Anyway, that's all going to get fixed when the HTML output gets a revamp. But we're going to go here and we're going to load that file that we created off screen. Oh no, that's fine. So I've loaded the Scratch version to here, and then we'll click the flag thing and it says start game, just like you wanted, and we go here, and actually this works the same. It shoots a lot of bullets sometimes. I'm pretty sure I got the random number things to be consistent across everything, because that command wasn't a Scratch command. I had to change the random thing to match how Scratch does random numbers. And so it all works fine. Should be able to get hit. You get hit without using the bounding box. You don't use colliders in this. It will use the standard Scratch thing. So it's probably a bit harder in Scratch. But as you can see, it's all working. And if we were to look at the code, clean up blocks. That doesn't help. Clean up blocks. There's a whole bunch of code here. You can see it's actually creating things here. Some of these don't actually do anything. Where's an interesting thing? So it's hard to explain, but a lot of this stuff here is what's managing the code for the scenes and stuff. So everything kind of works. What didn't work beforehand, and this is kind of interesting, is when I had code in here where I was using booleans. So you can't use booleans in Scratch because Scratch doesn't have booleans. So the player, I think it was in here, you'd be doing some weird thing where you say if move right. So if we have to look at the code for move right in the enemy, do movement, if move right. So before, I actually just had this variable straight in the if block, which you can't do. You can't write code like that because it's not a rounded variable is not going to fit in a sharp pointy thing because it's not a boolean. Except if you loaded it into Scratch 2, it would work and you could see it and you just couldn't edit it. And in fact, it would load into this as well. It would load into Scratch 3 as well, and it would work, but you can't actually look at it. So if you looked at it, it would forget all the code because it would say, "Oh, I'm trying to render this code, but it's wrong," and then it would throw it all out. Which I think is a kind of interesting little quirk. You could use that for like a protection scheme. Like if you actually load the game in and you just click the flag, it will run, and if you looked at it, it wouldn't work anymore. And in Scratch 2, you could look at it, but if you tried to save it, it wouldn't work. So now it's got if move right equals 1 equals 1. So if this is basically saying if this is true. So if it equals 1 equals 1. So this is a trick to get Scratch to output the Scratch outputter to output valid code using booleans. So that was part of the problem from the last video. Hold on. Yeah, I'll make it through the night, don't worry. I could edit these things out, but I'm not going to. Now, so we've done this. Now the problem is the HTML output is a different speed to the other two outputs. So I see I'm maxing out my microphone. And the problem is here. There's this line here, which is the wait movement delay, which I was going to change, right, over time. The problem is this loop is not happening every every 0.1 seconds. It's actually happening every 0.16 seconds. And the reason for this is that I do all the code, I wait time, so I start my loop and I do this and I wait the time. So this waits 0.1 seconds. So we've waited 0.1 seconds, 0.1 seconds passed, and then we do this code. And we forget this part here because we're not doing this. When we get here, at the end of our oh my gosh, at the end of our while loop, okay, maybe I can't do this video. At the end of this while loop, it because I've moved things around and there's been an update to the screen, because I moved the enemies and I waited for them to happen, what happens is there's an extra delay because this will now yield to the next frame. I don't think I can do this. I'll stick with it. We'll stick with it. We'll stick with it because I don't want to make this video ever again. So anyway, the thing is, at the end of this frame, so then we get an extra 0.6 seconds. So we get an extra 30th of a second, which is, if I do my maths, 1 divided by 30. It's 0.3. So it's 0.03 extra time. And maybe you're getting a few extra bits in there as well from doing other parts of the code. Now the problem is, so I spend a lot of time making sure that the internal runner in this thing acts like Scratch. So that's why they both have the same behavior. But I made a mistake somewhere in the HTML thing, and it doesn't actually have this extra delay. So it's basically doing less delays than the other ones are. Now, what you could do, I tried this, right, is you could go block level code do level, something like this, and then just take the whole thing and put that in here. And then make that a run at full speed. But it's running at full speed except for here where it waits, and that's fine. So it will wait, and then it won't be doing any running at full speed. And it will wait 0.1 seconds, and then it will do all the code, and then it will go straight back into this, and then wait 1 second. So you get the proper behavior if you do this. And so down here you wouldn't have all this stuff. You would just say do level. But we're not going to do that. If you do this, Scratch has a meltdown. It doesn't like, if you put this in a turbo block, a run without update block as it says, and you try and do a wait time thing, it doesn't really work very well. I don't know how it's written, but it works sweet as when you do it in my code, and I will prove that. But it doesn't work sweet as. Incomplete token. What have I done wrong? Oh, right. Sorry, commented it out. So when you run it, it moves now at the same speed, kind of, but that's 0.1 seconds. So it's just that 0.1 is too low. It should be higher. So it works all fine, but yeah, as I said, when you do that in Scratch, it doesn't like it at all. It doesn't seem to like if you have if you have a block that says don't update the screen, and then you put in some wait stuff, it doesn't just like yield and pause. It seems to be doing a lot of stuff in the background, so it's grinding away when it shouldn't be. So we won't do that approach. But what we will do is we'll think about how we've done this code. So let's just assume that, the thing is, you can't, like, it's not good code to assume that wait time is going to get you what you want, because there's other pauses that are just going to come out because of the way that Scratch and these things work, and Glitter works, where it has this automatic yielding to different frames depending on certain things that you can control, but if you try and control it, Scratch doesn't like it. So what we're going to have to do is we're going to have a new variable, float next time equals 0. So at the start of this, we'll say next time I'm not entirely sure this is going to work. So how do I get sensing? This is touching, blah 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 blah. Get current timer. So that, alright, there is timer. Okay. Timer. Alright. So how are we going to do this? Well, we're going to say it's going to look kind of a bit chunky here. I think I put wait frames. I can get rid of these things. If the timer is less than next time, well, we haven't done anything, so we will yield, or seed as I've now called it, which means I'll just pass it on and we'll just do nothing for a frame, and then we'll worry about it next time. And then otherwise we'll do all the code that we were doing before, except in this code we're not waiting time, we're not going to do that. We're going to add, so we're going to go next time, it's not next timer, it's next time. Next time plus equal movement delay. Alright, so what this is going to do is it's going to say when we come into this loop, if we haven't reached the next time, then we will just not do anything. We'll just seed, we'll yield. So I still want to use the word yield, which you can still use, but I can't because it uses a keyword and something else. And seed doesn't sound like a very good word, so we'll work out that later on. But you can use yield for now. So anyway, otherwise we will in Scratch this will be a wait 0. Otherwise we'll make the next time to be the current, or plus, we'll increase the next time by the movement delay, and then we'll do all our movement stuff, and then we'll come back here. So let's just say that next time starts off being the current timer. So the current timer is, I don't know, 100. Alright, and then we go into here and then we read this. The first time you go through the loop, the timer will be the same as it was before. So the first time you do the loop, it won't do this. It will actually do the code, because next time will equal to timer. And then we're going to add in the movement delay, which is 0.1. Alright, but we're going to make it 0.5. So we're going to say that the movement delay is 0.5. 0.5. So it's real slow. So next time, so then that's the next time. So the next time we come into the loop though, it's going to only have moved on to the actual time will be, say, 0.1. It'll be 0.03 or something, and then it'll be 0.6, and then it'll be about 0.1, and so on and so on and so on. So it won't actually get up to 5 for a while, and each time you come through the loop, it will just seed and seed and seed. Once we get to 0.5, we'll make it 101.0, because we'll add 0.5 down the bottom here. So the loop is going to go through here. It's going to, most of the time, it's going to do nothing until the timer actually eventually gets to the next time, and then we're going to increase it to the next time. So we're kind of pushing the goalposts every time we come here. But every time we get to the goalpost, we do some stuff, and then we push the goalpost a bit further forward. And the nice thing about this is this bit of code here could take way too long. Oh, we did something silly. Which we do actually do, of course. We do this thing here, which will go through and make the sprites go down too quick. You know, this will take a couple of frames, so this will take time. So you might actually end up, the next time you come into the loop, and you were here, it might actually be 0.6, but then you'll do it. But then the next time will still be 1. Right. If that makes any sense. And this is nice because it doesn't matter what happens at the end of here. Say I actually do an extra frame pause at the end of the loop, or I don't do an extra frame pause. I'm still running it basically on the same clock. It might not be exactly precisely the same, but it will be running to the same sort of clock no matter what I do. And also the thing is, my delay might be a bit weird. The thing is, you're not going to get it going up in nice little numbers. It's not going to, the timer in each loop it's not going up like 0.6, 0.7. It's always going to go up roughly 1/30th of a second if you're running at 30 frames per second, and if it's 60 frames a second, it will go about 1/60th of a frame per second. But now you can you can be more precise. So my movement delay can be 0.5. That might not match up with what the timer actually is, but you can go down to 0.049, and it will still be fine. So it will just be that most of the time you wait 5 frames, 5 frames to get to the next thing. But occasionally you might wait 6 frames or something like this. But anyway, I think this is going to be a better way of doing this. Let's see if it runs. Okay, we enter the game. And now it's going at half a second, which is not as slow as I was expecting. But it should run the same. So we'll just run the exporters. And we'll go back here, and then you can't really tell, can you? Because they're so slow, you just have to take my word for it. They're at the same speed. But they both work. Everything's fine. But what we could do is we're going to make movement delay now equals so how many, what did I call these things? What we will have to do is add in some variables. Int initial enemy count. Where does setup wave get done? Alright. Initial enemy count equals it's been a while since I've done this. Where did enemy count come from? Enemy count equals 0. That's the same as count. Why am I doing it twice? Who knows? Anyway, the initial enemy count equals enemy count. We could do this in the start wave thing, but we'll do it here. So we've got our initial enemy count. So that we know how many total enemies there are. And we can go down here. So we're going to divide that by how many total enemies there are. And we're going to multiply it by our enemy count. And we're going to add in base movement delay. And we're going to change these things. Movement range. Movement delay range. And what we will do, and we're going to put this at the top of here, I think, because it doesn't really. And then we'll go up here. And we're going to forget these things. I know I've called them doubles. You can just say the word float. Whoops. Float. So we're going to put this at 0.6. Right? And then we're going to have the base delay equals 0.05. So this is the range so basically this means that when all the enemies are there, the movement delay will be 6 plus the base of this. And as the number of enemies decrease, we will take less and less proportion of the 6. So if we get down to like half of them, we're going to have 0.3 of a delay plus 0.5. So this is just base movement delay is the fastest we'll get, pretty much. Almost, because it won't be 0 here, because then the level will be over. So does that work? Let's just find out. We've got some error. I gave the name wrong. Initial enemy count. What did I call it down here? Sorry, I have to find out my spelling mistake. Well, they look the same. Do I have to put them at the top? I don't think I do. Oh, I do. That's interesting. All right. Something to fix for the next time. So, well, actually, no, that makes sense. That's the way that this code works. Yeah. Anyway, that's for another day to explain what's going on there. Anyway, we'll start the game, and then we'll move. So it's going real slow, and then as I shoot them, you can actually kind of see it starting to speed up. It doesn't do that sort of jumpy speeding up. It's not really as fast as I was kind of hoping. You kind of want it to go way faster than that. But that's the base speed there. So obviously we've got some problems. That's way too slow. Let's see how we go now. Because we really want those things to move along. Only thing is you can't do more than one movement per frame. You can kind of see how it's stuttering a bit. That's because, as I said, what's happening is, oh, it works. That's basically full speed there, right? Because we aren't allowing it to move more than, we aren't changing the speed that we move at. So we kind of would have to change it so that we move faster. Because we don't have the time accuracy. So I think in order to get it to look really good, you'd probably need a bit more fancy code. But everything kind of works. We'll explain one day why variables declared after an object don't show up. Because you can do some very slightly clever stuff that I'm not going to talk about. But anyway, we don't need this code. So thanks for watching. I've stopped coughing. I think we'll leave it there because I don't want to do anything. I was going to do oh, if they get to the bottom of the screen, you die as well, but I can't be bothered. And oh, that was the thing I didn't mention in the scene video. Whoops, I just remembered now. Anyway, thanks for watching. Yes, I will put this video up, and I will tidy this code up, and then I will upload it to the website, as well as build number 2, so that you can try this at home. So thanks for watching, and goodbye. Interesting.